Hello everyone, welcome back to the another session. In this session, I'm going to discuss about the importance of acceptance angle in sending the signals through the optical fiber. That is, in sending the light signals through the optical fiber. As we discussed in the like a introduction to the optical fiber point of view, optical fiber is act like a waveguide which can able to send the light signals from one end of the fiber to the another end of the fiber by using the total internal reflection principle. So the meaning of total internal reflection is clear. That means the ray need to travel from the denser to the rarer, and at the same time the angle of incident at the denser medium should be either equal or greater than the critical angle. That's clear, right? So obviously if you want to send the signals through the optical fiber, then these conditions are need to be satisfied, right? If what happened if the conditions are not satisfied, then obviously the light is not moving forward using the total internal reflection. The obviously light enter into the another media, that is also called as, technically it is called as cladding. Light is moved from the core to the cladding, then obviously the light is not getting into the same media like a core part, because it is violating the total internal reflection principles, right? Then what is the situation, how you can control that kind of situation at the core cladding boundary? How you can able to maintain the total internal reflection conditions at the core cladding boundary? On factors it depends. Obviously the light is launching from the air media or the outside media to the optical fiber, right? We are launching, that is, initially the light source is placed outside the optical fiber and the light signals are launching into the core of the optical fiber. Then these rays are passing inside the core and it meet at the core cladding boundary. At that particular boundary it will check whether the conditions of the total internal reflections are matching or not. If it match, it get into the same media with the help of total internal reflection condition. Then obviously this incident angle at the core cladding boundary relate to the total internal reflection depends upon the launching angle at the air core interface. So obviously only limited angle, up to limited angle it can able to match the conditions of the total internal reflection at the core cladding boundary. Above this, so it is impossible to maintain the total internal reflection, so obviously the rays enter into the cladding. That's what about that. Because of this, the launching angle at the air, that is from the source to the air or any other media other than the core and cladding. So initially the light launching angle is strictly we need to maintain to match the conditions of the total internal reflection at the core cladding boundary. That's why this term is called as acceptance angle. That is the angle at which the ray can propagate through the optical fiber. That way is called as acceptance angle, because of that particular angle at the air core interface or any other media to the core interface, because of this only total internal reflection is appear at the core cladding boundary. The ray can travel in easy way to the other direction. Otherwise there is no possibility to get into the same media, same core. So there is no possibility to pass the light ray signals from one end of the fiber to the another end of the fiber. So I hope it's clear why it called as acceptance angle, because in that particular region of angles only limited version, only up to particular limited angles there is a possibility to get the total internal reflection within the core cladding boundary. Otherwise it is not possible. That's what it called as acceptance angle. It is one of the most important monitoring parameter, especially to launch the signals or to pass the signals through the optical fiber. I hope it's clear why it called as acceptance angle. Thank you.